Not a big deal. Okay, so which problems do I have? I'm like looking at the ones like I have to skip. It sucks. So sad. Like that one. This one. Ooh, this one's crazy. This one's a good one. Wait, what do I want to do? That one first or this one first? We'll do this one first, and then we'll do the other one. Oh wait, no, we can't. See, we can't do that one. No, it looks like we're doing this one. We can do this one. Okay, I'll do this one, then that crazy one. Alright, so solve. Sine of 2x plus cosine of x equals 0. Alright, so in our last equations, it was just one trig function all the time. Now you have two trig functions. So, yeah, I know. See, I told you I got a little bit harder. And then last, I just said that you're not going to have double angles in there, but now I gave you that double angle. We can have that double angle because you actually know what that equals. I can't put a 3x in there. That's the stuff we're going to skip. But what does sine of 2x equal?
2 cosine of x sine of x.
Yep. So you want to, two things you want to have. You want to try to get it down to one type of trig function if you can, and the same kind of angle. So x's, not two x's and x's. So you want to try to get it down to those things. Alright, so you have 2 cosine of x sine of x plus cosine of x equals 0. What do you want to try to do from there?
You factor out a cosine
Sure.
of x.
So kind of treat these functions like just variables. Like Logan saw cosine in common, so he's going to pull that out. So they both have a cosine, so you're left with 2 sine of x plus what?
Plus 4.
Yep, so just be careful of that. Alright. And now what do you want to do?
Well, can you just do like factor 0?
Yep. So then both equal to 0. Since they're factored. Alright, so now we got two equations we got to figure out. So the cosine of 0, or cosine of x is 0. So where on the unit circle is your x value 0?
Pi over 2 and 3 pi over 2.
Cosine.
Oh, pi and 2 pi.
I'm just going to put primary only. So that's from 0 to 2 pi. So 0, right? And so that's 1 comma 0. That's where x is. X is 0 at 0 and 2 pi, right? 2 pi. But in the note yesterday, I said if you look at this notation, one rotation, you start at 0 and then you go all the way around to 2 pi. You don't count 2 pi. There's no equal sign there. So you're not counting that spot twice. So in one rotation on the unit circle is this spot. Every spot is only counted once. So you hit everybody just once. So you wouldn't hit that spot again. So you don't count that again in your solutions.
Oh.
So, but don't count 2 pi. Okay, you already got that at 0. You already got that solution. So for us, for that equation, x equals 0. That's the only solution in one rotation. Excuse me. So sometimes you get two answers because there's two spots in one rotation. Sometimes there's only one spot in one rotation. For that guy, it's only one spot. You don't count the 2 pi twice. And then 2 sine of x plus 1 equals 0. How would I solve that?
This is something where you can subtract the 1 over, divide it by 2.
Yep.
Isolate the sine x.
Yep. So now where is y at what? So y is negative 1/2 at what guy on the unit circle? Oh, that's a janky circle.
11 pi over 6 and 7 pi 6.
So the pi over 6 is, and it's negative, so Logan said 11 pi over 6, and this guy is 7 pi over 6, because you want the y's to be negative. So x equals, because the variable is x, remember that's just the variable, it could be theta, it could be t, so don't get confused with that. Our answers are 7 pi over 6 or 11 pi over 6. And again, just the primary, so you don't have to do the 2 pi k. So those are your 3 solutions. So it's not terrible. It's a little bit of formulas and a little bit of algebra. Like Logan said, it's algebra with some geometry, like factoring, stuff like that. Is that cool? Alright, now we'll do the crazier one. This one's just a mess. Alright, here's B. So same directions, primary guys. 2 cosine squared of x minus 3 cosine of x equals sine of 2x minus 3 sine of x. Get a pencil out for this. Alright, where do you want to start?
Well, I know the double angle formula for sine, so I guess I start there.
So remember, you want to get everybody in the same type of angle, so all x's. Oh, double angle formula. 2 sine of x, cosine of x, or however you want to write it, it's multiplication. Alright, I don't know if that's okay if you need that light. It's a little light. Is that better?
Oh, yeah.
Okay, sorry. Sometimes the light makes it too bright where you can't see. Alright, now what do you guys want to do?
So, are we pretty much just expanding everything out?
Yeah, we did. So there's not much else to expand out. Like, there's no other formulas in there. Technically, there's one more, but I didn't teach you, so we can't talk about it. But we don't need it to do this problem, so we're good.
Well, I see that there's a 3 on the left side and a 3 on the right side, so I don't know if it's worth moving some things around to group, or I don't know.
Yeah, I'm just looking at something very quickly. Okay, so yes, but before we do that, I was looking at it and my brain was like gone. There's an exponent here, right? See this cosine squared? So in general, with exponents, why would we want to move stuff around a group? So anytime you have exponents, what do you usually do? You can factor. So Kelsey's grouping stuff is good, but that's because there's exponents. So anytime you have exponents, you want to get it equal to 0 so you can factor. So you still want to kind of treat these like equations. Like you see exponents, get them equal to 0. You see stuff you can factor out, factor stuff out. So let's move stuff around like Kelsey wanted. Get it equal to 0 so we can go from there. So 2 cosine squared of x minus 3 cosine of x minus 2 sine of x cosine of x plus 3 sine of x. I move everybody to the left, equals 0. Alright, so where do you want to go from there? I'm looking at my notes. Do they all have something in common? Like all 4 of them? Like the last problem, they had cosine, so we factored out a cosine. Do these guys have something in common? Like all 4?
I'll put the last one. Yeah, I was going to say, if the last one was a cosine, then yeah, but...
We don't. So what's another way we can factor?
Rearrange them to group them?
Yep, we can group them. as they're sitting pretty right now, like these guys have cosines and these guys have sines. So I'm going to group those guys. So I'll factor out a cosine and factor out a sine. Now do you want to factor out, okay, let's go from there. Let me shut up. Cosine of x from these guys. So I am left with 2 cosine of x minus 3. Is that cool? Is that factoring? So you take out a cosine here, you're left with a cosine. And then take out a cosine, you're left with a 3. And from this guy, when you factor out a sine, do you want to do a positive sign or a negative sign? This is a
negative sign.
Because this guy's negative over here. So negative sine of x times, you're going to be left with a positive 2 cosine of x. And here you're going to...
Maybe I should have... Oh, I guess it doesn't matter.
What? What were we going to say?
Because, like, the factor is 2 cosine plus 3 on this side. And... Oh, wait, no.
It works. It's perfect, yeah. Because now this guy's going to turn into a negative.
Yeah.
And it'll match that one. So minus, take out a negative sign here, you get minus 3 left. Equals 0. Yep. So now we can group. They both have this guy in common, so 2 cosine of x minus 3 comes out from each. And then times, we take those out. What's left is a cosine of x minus sine of x equals 0. So now it's factored. Craziness. Alright, so now that it's completely factored, something times something equals 0, we can set both pieces equal to 0 and solve. So 2 cosine of x minus 3 equals 0, or cosine of x minus sine of x equals 0. Who is that? Is that
I
Logan?
just need him back by like 2023 because that's when my brother comes back.
Who is that talking?
Sorry,
Oh,
I opened up a
that's
snap.
awesome.
My friend just... I was like, what?
That's hilarious. I was like, whose little brother or sister is that? I know. Oh, that's great. I was like, that was weird. At first I thought it was Kirsten popping up, and I was like, no, she's not here. No, it's too funny. Okay, so let's solve these ones. I'm going to get this cosine by itself. So I'm going to add 3 and divide by 2. Okay. So where is cosine of x equal to 3 halves?
Never.
Never. Good. It's bigger than 1. That's 1.5. It's gone. And then where cosine of x, I just rewrote this. I don't know why I did that, but whatever. Solving this guy. Cosine of x equals, you know, I think it's like too bright. Is that better now? See? Sometimes it's too bright, right?
I mean, that's fine too. Yeah,
Okay.
whatever.
I feel like the other one was bright. Alright. So normally we only have one trig function. Like, that's it. One trig function equal to some number. Right now we don't have that. I'm going to get cosine equal to sine. So I'm going to add sine of x over. So I added sine of x over. We're still stuck with 2 trig functions. But look at what this statement is saying. It says cosine is equal to sine of x. So when is cosine and sine equal?
When they're both pi, or square root of 2 over 2, so the 45 degree angles.
So
Pi over 4.
yep, at pi over 4. So let's look. So at pi over 4, they're both positive square root of 2 over 2, comma square root of 2 over 2. Where else are they exactly the same? What about in quadrant 2? Are they the same there?
In quadrant 3.
Quadrant
Yeah.
3.
Because Here they're one positive, one negative, so no. Here they're both negative. So which pi over 4 guy is that?
5.
Careful. Is it? Oh, it is. I was thinking the pi over 3s. Good job. Pi over 4. I was thinking 3 pi over 4. That's what was I thinking? I don't know what I was thinking, Logan. Terrible deal. 1, 2, 3, 4, 5. Good job. What was I thinking? 4 pi over 3. That's what I was thinking. That's 4 pi over 3. Alright, so at pi over 4 and 5 pi over 4, they're the same. So our variable at x equals pi over 4 or 5 pi over 4. And this was only primary, so we don't need the 2 pi k. So that one was pretty cool. Oh, this is my piece right here. The other one I have, I can't, you guys don't know that formula. Although I can manipulate it like for homework and give it to you guys to study or whatever, but as it sits, I can't give it to you. Alright, cool. So those are as crazy as they get. Crazy factoring, U sub, maybe a little bit more thinking in terms of your trig stuff, but that's about it for those guys.
I mean, you could definitely get lost in it.
Oh yeah, that was a lot going on there.